Hi, my name is Michael Alexander Tröls, and I'm presenting timestamp-based consistency checking of collaboratively developed engineering artifacts. As you know, engineering projects require an orderly coordination of engineering artifacts. Engineering artifacts are simply the results of an engineer's work or a byproduct thereof. For example, UML designs, code, requirements, specifications, and others. There are, of course, dependencies between these engineering artifacts, and when you change one engineering artifact, others might potentially have to change with it. So for example, if you change UML diagrams, you may have to change code that is documented in that UML diagram. These changes need to be checked for consistency. And we can do this with live consistency checking for heterogeneous engineering artifacts or global consistency checking in a uniform hierarchical artifact storage. I will talk about that in a second. The problem with the existing solution is that it continuously updates artifact states and their consistency. And this may be undesirable during certain work procedures, for example, bug fixing. You don't want to continuously update your artifact state when you are looking at a certain bug. So therefore, uh, we want to configure consistency checking with timestamps. So let me tell you about global consistency checking really quick. What we do is essentially we equip tools with tool adapters, and we incrementally synchronize engineering artifacts, respectively changes thereon, with an artifact storage. And this artifact storage hierarchically stores changes on engineering artifacts and stores these changes in a work area hierarchy. I'll show this to you in a second. So every time you synchronize a change with the artifact storage, a change event is fired and the consistency checker looks at the artifact storage and uh, sends feedback to the tool adapters, respectively the tools used by the engineers, telling them whether their change is consistent. So within the artifact storage, as I said, there is a hierarchy of layered changes, basically a tree, a hierarchy of work areas. You have a certain uh, work area, a parent work area that contains an artifact and its properties, here variant and length. And then you have child work areas here, work area A and work area B, that only contain changes on this artifact. And the work area together with the root work area forms the perspective of a tool on a certain artifact. So tool A has changed variant to B, so the change is in work area A, and tool B has changed the length to 0.75, so that changes in work area B. However, the properties that are not changed, those are retrieved from work area P, so variant A here and length. Now, if one of those work areas is committed to the parent work area, it automatically updates the perspective of all sibling work areas. So tool B now sees variant B. How are we consistency checking in this setup? Essentially, we are looking for change events within the work areas. We retrieve rules, consistency rules, essentially, here represented through a CRD, a consistency rule definition. We gather all data necessary for a consistency check of that consistency rule, and we perform a rule evaluation and write the result back as a so-called CRE, a consistency rule evaluation artifact. And these are also stored in the work areas, of course. So every work area has its own consistency state. Now, you may not always want this continuous update of consistency states or artifacts. So what we do is timestamp-based consistency checking. We essentially equip work areas and there are changes with a timestamp at the time of the work area's creation. And we equip the parent work area with a timestamp that corresponds to the last commit, in this case variant B, right, with T2. The properties at different timestamps form a version history against which the work areas can check their changes depending on timestamp configurations. And we have three timestamp configurations, one for work area, for the root work area, and for past or intermediate timestamps. So let me give you an example. For example, we have the rule variant, if variant is A, then the length must be greater or equal 1. And if we look at this rule from the perspective of work area B, if we choose the work area configuration for our consistency checking, and TB here, so the timestamp of work area B, would be T1, so timestamp T1, then that consistency rule would break because length here at T1 would be compared to variant A, and that is less than 1, so that is inconsistent. However, if this was compared to the root work area configuration, which is T2, then the variant would be B, and that would be fine, so that would be consistent. And for any past or intermediate timestamp, that would also be fine because the only intermediate or past timestamp here is T0 and their variant was not set, so that is consistent again. So that's how we equip our consistency checking with timestamps. And you can read about this in our paper, timestamp-based consistency checking of collaboratively developed engineering artifacts. And if you have any questions, please let me know. And I thank you for your attention.
Okay. So, I'm happy to answer any questions on the presentation you just saw. I actually did not see it because in the backstage rooms we cannot see it. But yeah, if anyone has any questions on the topic, please type them in the chat and I'll try to answer them as well as possible. So right now I'm not seeing any questions yet. But yeah. Okay, so one question is, how large are the rule sets with which you work? Generally speaking, we work with standard rule sets that are applied in the realm of UML mostly. So that is basically our test set of rules. And there are rather generic rules you can apply in a lot of different projects. And we on our own for most of our tests have been working with around 10 rules, 10 to 13, 10 to 20 rules that are tested on differently sized projects essentially. So that is roughly the rule set, the size of the rule set. So how do you see? I hope that answers the question. How do you see this work moving forward? That question I can answer in the following way. Mostly, the work that is currently conducted on this is about usability. So how to really integrate this technique, this mechanism, this tool essentially, into the workflow of engineers, so it's actually usable for their everyday work. And for that, of course, you need to program, or you need to create tool adapters, so you can actually do the respective case studies in this sense. So I hope that answers your question. And
Thank
next,
you, Michael. If I can just
okay.
jump in, I think we've
Yeah.
got my connection sorted. So we've time for one quick question, maybe one
Okay.
moment. And I see one from Marco Connorsman here. When and where do you apply the consistency checks? Is it on a developer's PC or in an integration server or something alike?
It is, the consistency checking is happening in parallel to the engineer's work on the server. It's important that the entire consistency checking mechanism is essentially more or less invisible to the engineer, so their work is not interrupted. So it is on the server. On the server, you essentially have your artifact storage, and you have a series of services analyzing these the storage content. And the consistency checker is essentially one of these services. And yeah, it looks at the storage, it looks at the changes, it analyzes the consistency, and then sends the feedback to the engineers.
Okay, so thank you very much, Michael. It's an excellent and very, very interesting area. One of the big challenges is tying up everything to be kind of synchronized, which is what you're trying to deal with. And it is really great to see the term or the word variant being used in a context other than COVID-19 at the present time. So thank you very much for that. Also, reminding us that it has other uses.
The next talk we will see also on that topic will be a bit more general, so we can then again talk about that.
Okay. Okay, great. So I'll just briefly introduce the next piece of work. So the title of the next presentation is an empirical investigation of pull requests in partially distributed themes, and the authors are from the University of Oslo and also from SINTEF. We have